is basically the energy resource which is being generated from the waste, organic waste. Do remember that. So bioenergy is the resource, the energy which we generate that is from our organic waste. Uh, like when you people were in hostel and in the canteen, you people are eating. So the bioenergy resource is basically, the thing that we are, is like something, the waste which we are generating from, organic waste, like we eat something and we leave something. So that is being, fed into a big hole and grounded, and that energy is being converted into methane by the bacteria, and that methane is being used as a source of energy. So that is known as actually bioenergy, and it is a renewable energy resource, and it is a resource that is being it is being derived from the materials from the biological sources. So bioenergy is derived from biomass. Okay, like it can be derived from all the biological materials like wood. Biological material means those who are biodegradable. Okay, like wood waste is there, straw is there, manure is there, trees waste are there, leaves are there, grasses are there, sewage is there, garbage is there, and many other byproducts. Okay, that are means generated from agricultural processes, and we can generate power out of it from the biological resources, you can say. So bioenergy is the renewable energy, and it is made available from materials derived from biological sources basically, and it is derived from the biomass including wood, wood waste, straw, manure, sugarcane, trees, grasses, sewage, garbage, etc., and many other byproducts from a variety of agriculture processes. And it is renewable energy resources, and there is a complete cycle how it is being obtained basically, and bioenergy needs a continuous carbon cycle between the atmosphere and the earth. And someone is there again, Kapil is there. So in the bioenergy, in this cycle actually CO2 is taken from the atmosphere in the plant processes like photosynthesis. You all know what is photosynthesis, and it is converted into the biomass, and from this process additional CO2 is being produced and converted into the energy. So there is a complete bioenergy cycle is there, and we are using organic waste, and bacteria is basically decomposing it. So it is a cycle in which carbon dioxide is taken from the atmosphere in the plant processes, that is photosynthesis, and it is being converted into the biomass. And from this process, additional this carbon dioxide is produced, and it is being converted into the energy basically. And the energy which we get from the bioenergy is known as biofuel. So what is a biofuel? Biofuel is produced directly from the plant matter. Typically, normally we use corns in there and sugarcane, and we transforming into the alcohol also. Alcohol is being made by the fermentation process, and nearest we have in Yamunanagar there is a distillery, and they use sugar canes and corns and sugar canes to manufacture alcohol. It is also a bioproduct. Do remember that when it is formed by the fermentation, it is a bioproduct only. Alcohol is also a bioproduct. And if it is being misused, you all know what is the misuse of alcohol, and how it can be used in a good or a proper way, and how it can be used in a bad way. You all know that. And again, we say that basically biofuel is the fuel which is directly obtained from the plant method. Okay. And what are the fossil fuels? Fossil fuels are produced by either decomposition of plant or animal matter over a long period of time, and attain under the certain conditions like high temperature and pressure, and like coal, oil, and natural gas. And we have already discussed a lot in detail that fossil fuels are non-biodegradable, and we take a lot of time to generate these fossil fuels. And biofuels, if we go much more towards such energy processes where we get the bioenergy or biofuels or solar energy, it is always much more when we are using non-conventional energy resources, it is much more useful than using the conventional sources of energy like coal, oil, natural gas, etc. And then bioenergy types, we have both the types, traditionally and advanced. Traditionally, the sources which we use are basically wood and other biomass pellets. In the advanced scenario, we are requiring, converting biomass into liquid or gas form also in order to produce the electricity, like biogas, liquid biofuels are there, alcohol is there, ethanol typically, and biodiesels. We are manufacturing biodiesels also. And we categorize into three states like solid bioenergy and liquid bioenergy and gas bioenergy is also there. And basically biofuels are basically the sources of energy that we are deriving from the organic waste material. The network was gone, so I reconnected again. And biofuels are basically, they are generating energy on the from the sources that are available to us. That is, agricultural waste is there, and any of the organic waste that are being there. So basically, we are generating biofuels out of it. And these days it is being available in both the forms, solid, liquid and gaseous forms. And we are using it in a different purposes, for different purposes where we can use it. So it is also, one of the you can say the non-conventional sources of energy which can be, used for generation of power basically. So I'm again opening the PPT because network was gone, and again we are connecting. We were here. Like bioenergy types we were discussing. So bioenergy types are basically traditional as well as advanced. And as I was saying that it is basically the solid, liquid, and gaseous form which we are using these days. And all the three forms are available for the usage of this bioenergy. Like solid bioenergy, it is derived from solid renewable resources. Liquid bioenergy is derived from plants and animal fats. Similarly, gas bioenergy is being derived from methane, as I told you already, also, and carbon dioxide, which are produced when bacteria break down these biomasses. And solid bioenergy is directly used in, gasification and combustion technologies. Liquid bioenergy is like 2% of the transportation fuel today. It basically we are using the 2 percentage of transportation fuel out of the liquid bioenergy which we are generating. And later on, we will be looking for such technologies that it can replace our existing fossil fuels also. And if we talk about the gas bioenergy, the biomass used are basically animal waste, landfill waste, and municipal and energy crops basically. And examples, what are the examples of solid, liquid, and gaseous bioenergy? For the solid bioenergy, we have wood, sawdust, straw, husk, stock, bagasse is there, and all the construction waste we include into this. And for the liquid bioenergy, like bioethanol, it is made from sugar and starch from the fermentation processes. Biodiesel is there, it is made from the plant oil and animal fats, biodiesel. And gas bioenergy, if we talk about, basically we are using, biogas, biopropane, syngas, synthetic natural gas is also there. So in the gas bioenergy, basically it is derived from methane and CO2. And how it is being derived, the bacteria, it breaks down the waste material and then we are generating it. So we have basically in the advanced form, we have solid bioenergy, liquid bioenergy, and gaseous bioenergy. Now, what are the primary energy conversion technologies? We use three: combustion, gasification, and pyrolysis. Pyrolysis is also known as dry distillation. What is combustion? Combustion is the direct combustion of the biomass. It is the most common way of converting biomass into energy, both heat and electricity. And compared to the gasification and pyrolysis, which is also known as dry distillation, it is the simplest and most developed method. Now, what is gasification? Gasification is a high temperature, around 1200 to 1400 degrees Celsius, and thermochemical conversion process. And but the process is used for production of gas instead of heat. Now, pyrolysis, it is also known as dry distillation. The thermal decomposition occurring in the absence of oxygen is known as pyrolysis. As I already told you that it is also known as dry distillation. So we use basically pyrolysis to produce a liquid fuel, bio oil, or pyrolysis oil. It is also one of the biochemical process, and it uses microorganism to produce bioenergy basically. So these three processes are being used like combustion, gasification, and pyrolysis. So another name for pyrolysis is dry distillation. Now, in the figure, you can see how we can generate energy from the biomass. Like the three processes which we discussed, pyrolysis, like the dry distillation, is being used in charcoal and in barbecue and metallurgical industry, and in the liquid oil and in the fuel gas form also we can use. And the liquid as a liquid fuel, it can be used for the engines and as a fuel gas also. And we can also use for the generation of electricity by using turbine and generators. And combustion is basically producing heat like from the boilers and stoves, and we can directly use this heat for further our domestic purposes. So we are generating a lot of energy from the biomass, and further there is a lot of hope is there that we can still generate a lot of power out of it to develop such kind of technologies. Now, turning biomass into electricity, like all other powers, the same procedure is there. The biomass is first converted into the heat. The heat is being used in the boilers. The boilers generate the steams. Also, there is a condenser which cools down. The steam generated is used by the steam turbine, which is further connected to the generator, and for the generator to the transmission lines, that is the electricity. Okay. So steam spins the blade of the turbines, and that is the power is being used for generation of electricity. So the figure shows how we are converting, how we are actually using this biomass and turning this biomass into the production of electricity, basically you say. Now, what is the efficiency of biomass? The electrical efficiency rating of transforming biomass into electrical energy is around 30% for 10 to 20 megawatt capacity plants. Now, basically, our other power plants, they produce around 500 megawatt as compared to this efficiency of the biomass. And we are able to generate from the coal fired plants. It's an output is around 1000 megawatt, and biomass is we are only getting 30% out of it. So this is the actually the efficiency, and it is a little bit low as compared to the other fossil fuels. But we are working on newer technologies to generate more and more power out of this biomass. Now, biomass energy facts. If we talk about the facts of the energy, the worldwide biomass is the fourth largest energy resource after coal, oil, and the natural gas. And it is estimated to be about 14% of the global primary energy. Whereas if we talk about the US, it is only providing 3 to 4%. And basically, we are using for small domestic purposes like wood we are using as a source of cooking, etc. And fuels like ethanol, and they have been becoming much more popular for electric power generation. And installed capacity of biomass power generation worldwide, if we talk about worldwide scenario of it, it is around 35,000 megawatt, and with about 7,000 megawatt in US derived from the forest product industry and agricultural residues basically. Now, this figure shows the scenario where we are using biomass. We have biomass plants in the world. You can see in the figure that North America, South America, Europe, Russia, Asia, wherever we have these biomass energy plants, it is located by the red dots. We have now world largest biomass power plant is in Poland, and you can see the plant. And Poland is a very peaceful country, and they are using a lot of generating a lot of um, biomass, and they are converting that biomass into energy. So the world largest biomass plant is there in the Poland. Some other figures are there for the biomass plants. One is there in the Finland, one is in the Netherlands, in Sweden, in Italy, etc. And in India, you can see in Chhattisgarh, we have in Karnataka, in Tamil Nadu, in AP, and in another one is there. Two are there in the AP. So we are also using a lot of biomass for generation of the power. So India also we are using biomass. Now, what are the advantages and disadvantages of using this biomass as energy? It is a renewable, inexhaustible fuel source. Disadvantage: it could contribute a great deal to the global warming and particular pollution if directly it is burned. There is a minimal environmental impact. Still an expensive source both in the terms of producing the biomass and converting it into the alcohols. Alcohols and other fuels produced by biomass are efficient, viable, and relatively clean burning, and it is available throughout the world. The one of the biggest advantage and disadvantages, it is on a small scale. If we install a plant, there is a net loss of energy, and energy must be put into the grow the plant mass. So these are some of the advantages and the disadvantages of using the biomass, and these are the greenhouse emission by the transportation fuel and types of energy used in processing. You can see gasoline is there, and current average is basically 19%, and ethanol if we are using for production power, and then biomass is, if we use biomass, there is a 52% reduction is there. If we use sugar cane or ethanol, 78% reduction is there, and if we use cellulosic ethanol, means ethanol that is being derived or manufactured from cellulose, 86% reduction is being there. And we can use this biomass into architecture also. Uh, like the waste is being used to produce many products in the architecture. Some of the uh, details are given in this, and one of the application is there in architecture also, in building. We from the waste we manufacture the building material and other LED certification for because it is a renewable source of energy, and wood chips are basically being made from this biomass and other things also. So this is all about the biomass energy, and it is one of the, you can say, uh, one of the latest things which are being used for generation of electricity basically, and there is much more potential to it, and we can use biomass more for generation of energy. So let's